In this part, we are going to talk about radio frequency. Radio frequency, or RF, is any of electromagnetic wave frequencies that lie in the range starting from around 3 kHz to 300 GHz. As you see, it's starting from intermediate frequency and ends in really high frequency. What is the purpose of using RF field? We say RF field can be used for various types of wireless broadcasting and communication. So we use transmitters and receivers and also antennas in order to send and receive data and communicate. What are the applications? We can say there are lots of applications for radio frequency: cell phones, radio, television, Wi-Fi, and even if we go more advanced, we can have satellite communications. This picture shows the RF system in a very simple way. So imagine that we have two devices, 1 and 2. So they are trying to communicate and talk with each other. So they are sending and receiving these waves, and they have their data inside these waves. So as you see, these electromagnetic waves have the radio frequency. So there are two cases in this system that we have to study. First, we can say, for example, this device can only send data, and the second one can only receive it. So this one is sending and it's in one direction. So, and this one is receiving. So we can say this is a transmitter. So this is TX, we call it TX, and this is receiver. So this is RX. And it can be also different case. For example, these two systems can be TX and RX at the same time. It means that this device can send electromagnetic wave to the second one and also receive from second one. So this time this is TX RX, and we are going to talk about this in upcoming lectures. There are 2 points we have to be careful in RF system. First one is these systems are trying to communicate with the waves that have RF frequency. So we say we have radio frequency here, RF, and second one is these two systems are not connected to each other physically. There are no connection between them physically with a wire, for example. So we say the system is wireless. The RF spectrum is divided into several range or bands. With the exception of lowest frequency segment, each band represents an increase of frequency corresponding to an order of magnitude. So we are going to explain the RF spectrum in the following table, and as you see in this picture, we can divide the RF frequency range into different groups. So we start with very low frequency. It's from 9 kHz to 30 kHz, and it goes to a low frequency, and it goes on and we reach the extremely high frequency. Here is from 30 GHz to 300 GHz. So we call this spectrum. As you see, the range is divided into different categories, and we most of the time allocate this range to different kind of applications we are going to show in next slide. And what about the wavelengths? We have to explain the wavelengths here because we are going to use it. We say the wavelengths is equal to speed of light over the frequency of oscillation. So wavelengths is lambda here, we show it with lambda, is proportional to inverse of frequency. It means that if we increase our frequency, we are reducing the wavelengths. So as you see here, the wavelengths for low frequency range is really high, starting from 10 to 33 km. But when we are increasing our frequency, we have a very low wavelengths. As you see here, it's a millimeter. So that's why we call this millimeter wave at this point. We are going to explain the wavelengths. Imagine that there's a water and you are trying to tap in the middle of this water. So you are producing wave. So what is the wavelengths here? As you see, if you see the cross section of the water, it's like this. So the wavelengths is the length between the two peaks of the wave. So for example, wavelengths is here. This is the lambda here. We can show it lambda. This is the length between two peaks of the wave. And the relationship between wavelengths and frequency is shown in this picture. As you see, for the first wave we have the frequency of f1, for the second we have the frequency of f2, and we say f1 is higher than f2, but as you see, this one has the short wavelength, so we say lambda 1 is lower than lambda 2. So this shows the relationship between the wavelengths and frequency.